Okay, let's start. Hello everyone, my name is Vladimir Ivashkin. Today we'll talk about calculators. Please, raise your hands if you use addition or subtraction in your everyday life. Sure, almost all of you do. Thank you. I'm very proud to present a new generation of calculators, Image2image Neural Network Calculator. Basically, the system gets your expression, for example 12 plus 3, then turns it into image, then feeds a neural network and gets an image of the result. We don't use actual arithmetic step inside the calculator, which makes calculation simple like never before. We will dive deep into details later. Now let's go through motivation and related work. Calculators have always been an important part of human being. The necessity to add and subtract small and sometimes large numbers went with the development of human civilization. There is a lot of previous research on this topic. Mechanical calculators were very popular in 1920s. They did addition and subtraction with one twist of the handle. Multiplication and division are also on board, but during a 10-minute examination of specimen we couldn't figure out how they do it. The invention of electronic tubes, transistors and microcircuits pushed the development of electronic calculators. The multifunctional battery-powered calculator became the pinnacle of human creation. It combines unsurpassed efficiency, usability and functionality. Then something went wrong. Mankind came with computers. A heavy-duty computer stores an operating system and random access memory and runs it in endless cycle. Its video card draws 60 frames per second and all just to display a calculator. Monitor shines with pixels without using sunlight. The functionality of the calculator was simplified, but energy consumption was 100 times increased. Did we humans stumble in calculator design? Maybe. Did we find the right way? To the best of our knowledge, no. Modern calculators are either an application on some device or even a web page. Mathematical expressions are a big part of all queries in search engines. In addition to increased capabilities and electricity consumption, this method demands the internet connection, which is a very complicated thing just to add two numbers. To summarize this survey, calculators are getting slower and simpler in functions. Our calculator is a logical extension of previous work on this topic. Now let's go to the method part. We propose an image-to-image neural network to perform mathematical operations. As there is no suitable dataset for training our model in the literature, we collect our own. We find that it is possible to create a paired dataset of mathematical expressions and corresponding answers. For example, 5 plus 2 and 7. Calculators of previous generations are used to collect the data. For each pair of expressions and answers, we generate a pair of images using random nice digits of the corresponding class. We choose our glass U-Net-like architecture for our network. The main difference is that we remove L-skip connections and add several linear layers in the bottleneck. It makes the model no longer look like U-Net though. The neural network is trained with both GAN and perceptual loss to encourage diversity of different lettering. Using the procedure described above, we successfully trained our neural calculator. It inputs two integer numbers between minus 99 to 99 and is able to perform addition or subtraction. According to our experience, this covers almost all daily needs. For the details of the realization and cherry-picked results, please take a look at our paper. Also, we have a demo page, so you can already start to use our calculator. Link to a demo is also in the paper and maybe somewhere else. We hope that the audience will appreciate the importance of this work and begin to use a more advanced calculator and enter a new calculation era. We cannot but note that the neural network managed to learn simple arithmetic only from training on images. It is possible to train a model that first turns an image into numbers, performs the arithmetic and then renders an image of the result. This is not how our model works. We do not have an explicit arithmetic step in our network, but it is still able to generate correct answers. It could mean that neural network has mastered the concept of number. The ability to understand concepts is a key part of true artificial intelligence, so we expect our model to grow and calculate all the things we need. Thank you for listening. If you have any questions, you're welcome.